Lesson 5-6 is solving absolute value inequalities. So we're just taking it a step further, and basically if you have the absolute value of x equals 3, we know that the answer is 3 and negative 3 because both of those are 3 units away from 0. But if we have the absolute value of x is less than 3, it means that x has to be within 3 units of 0. So here's an example of what that's going to look like. And we can see here that we're shading in between, or the arrows would actually go together so they get wiped out. So this is going to be an and, which is an intersection. And if we have x, the absolute value of x is greater than 3, we know that x has to be more than 3 units away from 0. So this, as you can see with the graph, is going to be an or, which, oh come on, an or, let's see if I can get the word or, which is a union. So let's go ahead and check out some of these. So if we have the absolute value of x is greater than or equal to 6, we know that the x has to be within 6 units, or I'm sorry, it has to be greater than 6 units away from 0. So we know that x has to be greater than or equal to 6, or x has to be less than or equal to negative 6. And when we graph this out, if I put 0 here, 6, negative 6, anything from 6 to the left or to the right is greater than the absolute value, and anything from negative 6 to the left is going to be greater than, and this is greater than or equal to 6 units from 0. Here we have the absolute value of x is less than or equal to a half, so it means that it has to be within a half unit away from 0. So we'll have a negative half here and a positive half, and the x has to be within this range right here. All of these numbers are less than or equal to a half unit away from 0. So we would write this as negative half is less than or equal to x is less than or equal to positive half. And again, going back to what I had on the first slide, greater than equal to is going to be an or, less than or equal to is going to be an and. And that is basically what this is saying right down here. So see right here, it's showing you greater than is an or, and less than is, they're not using the word and, but they're writing it as that compound inequality. So let's go ahead and solve some of these more challenging problems. So we have the absolute value of 2x plus 1 is greater than or equal to 5. Well, this is greater than or equal to, so I know it's going to be an or. So the first thing I do is I take off the brackets and I solve it as is. So I would subtract 1, so 2x is greater than or equal to 4. And x then is greater than or equal to 2. This is an or. So remember from our previous work with absolute values, you still take off the bracket. Well, now I'm not just setting it equal to. Since I'm setting it to the negative 5, I have to flip the sign. So less than or equal to negative 5. And again, I will subtract the 1. So I get negative 6. And then I will divide by 2 to get negative 3. So when I graph this out, if I put 0 right here, x is greater than or equal to 2. So that's all of this. Or x is less than or equal to negative 3. So that would be all of this. Alright, absolute value of negative 4x minus 5 plus 3 is less than 9. Again, the first thing we need to do is put it in the correct form. So we have to subtract 3 from both sides. So I have the absolute value of negative 4x minus 5 is less than 6. This is less than, so it's an and. So when I take off my brackets, I'm going to go negative 6 is less than negative 4x minus 5 is less than 6. So I'll add 5 in the 3 places. I get negative 1 is less than negative 4x is less than 11. I have to divide everything by negative 4. And don't forget, when you divide by a negative, you switch the sign. So I have a fourth is greater than x is greater than negative 11 fourths is going to be 2 and 3 fourths. But this is not the proper form. Remember, for a compound inequality, you need the smaller number, because this is the lower bound portion, less than x less than the larger number. Oops. So I'll put 0 here, and I'm going to have, let's see, 1, 2, 3, 4. We'll make this a positive 1, so each of these are a fourth. Let's see if I did this. 1, 2, 3, 4. Negative 1, 1, 2, 3, 4. And negative 2, I need to extend this. 1, 2, 3, 4. Negative 3. I could have just moved it up, but oh well. So negative 2 and 1, 2, 3 fourths right here, open circle. And positive 1 fourth is right here, open circle. And we shade in between. All right, a couple more of these, and then as you can see, we're going to do a couple application problems. So I'll add 8 to both sides. I have absolute value of 5x minus 2 is greater than or equal to 5. This is an OR because it's greater than or equal to. So 5x minus 2 is greater than or equal to 5, or 5x minus 2 is less than or equal to negative 5. And again, I can only have the negative over here because the brackets are off with equality. So I'll add 2 all the way around. So 5x is greater than or equal to 7, or 5x is less than or equal to negative 3. Divide everything by 5, and x is greater than or equal to 7 fifths, or x is less than or equal to negative 3 fifths. All right, so we're going to, they were nice enough here to make it go in fifths. So 7 fifths, I can count 5, there's 7 fifths, and this is greater than or equal to negative 3 fifths, 1, 2, negative 3 fifths, this is less than or equal to. All right, here we have a couple of different things we have to do. The first thing we need to do is add 14. So I have 6 times the absolute value of 2x plus 9 is less than or equal to 30. Now I have to divide by 6. Remember, you do not distribute over an absolute value sign. It's like a big old wall you can't penetrate. So we get 2x plus 9, I still have the absolute value, is less than or equal to 5. This is an AND, so it's an intersection. So I'll go negative 5 is less than or equal to, now the brackets come off, and then less than or equal to 5. So if I subtract 9 everywhere, I get negative 14 less than or equal to 2x less than or equal to negative 4. Divide everything by 2, and I get negative 7 is less than or equal to x is less than or equal to negative 2. Notice, even though I'm dividing into a negative, I did not divide by a negative, so I do not flip the sign. So I have a negative 7 and a negative 2. So let's just start here at 0, negative 1, 2, 3, 4, 5, 6, 7. And they're both closed, and a shade in between. All right, here's some application. It says write the verbal sentence as an inequality, then solve the inequality and graph your solution. So the distance between 10 and 2x is greater than 34. So the distance between 10 and 2x is greater than 34. So now I need to go ahead, it's ready to go. This is an OR statement, so I can take off the brackets. 10 minus 2x is greater than 34, or 10 minus 2x is less than negative 34. When I solve this, I'll subtract 10, so I get negative 2x is greater than 24. Divide by Negative 2, and first I get x is less than negative 12. Here, do the same thing. So negative 2x, is less than negative 44. So x is greater than 22. So now, again, this is an OR statement. I'm going from negative 12 to positive 22. So let's see if I put my 0 here. 2, 4, 6, 8, 10, 12. Negative, open circle, less than. And 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And again, open circle. There we go. Okay, the average price of a standard DVD is $15.99 with a standard deviation of 4. Write an absolute value inequality that describes this range in prices. So I'm looking at the distance here, x minus $15.99, the absolute value of that is, it's got to be within $4. So we have to go less than or equal to 4 so it can be within the $4 range. So this is going to be an and, so negative 4 less than or equal to x minus $15.99 less than or equal to $4. So I'm just going to add $15.99 to everything, and $15.99 plus a negative 4 there is going to be $11.99, and over here it's going to be as high as $19.99. So the average price is going to range from $11.99 to $19.99. Okay, we're talking about a canine here, which is a dog. The body temperature is considered normal if it's 101 degrees Fahrenheit with an absolute deviation of 1.5 degrees Fahrenheit. So they want us to go ahead and write first the absolute value inequality, and that's going to be the absolute value of x minus the temperature, the healthy temperature, less than or equal to, it can only vary, within the 1.5 degrees. So there's part A. B, this is an and again, so negative 1.5 less than or equal to x minus 101 less than or equal to 1.5. So I take the 1.5 and I add it all the way around. The normal temperature for a dog is going to be between 99, I put my decimal but didn't put the answer, 99.5 degrees Fahrenheit to 102.5 degrees Fahrenheit. So dogs run warmer than humans because our average is 98.6. Okay, I do have the assignment if you want to get started with it. This is lesson 5.6 and it's page 343 to 345, problems 1, 2, 6 to 20 even, 21 to 24, 25 to 31 odd, 35 to 39.